Hi everyone, thanks for joining today's seminar series organized by the Empathic Computing Laboratory. I'm your host Pai, and our guest speaker for today is Enrico Rukzio, who is currently a professor in human-computer interaction in the Institute of Media Informatics at Ulm University. His research interest is in designing intelligent interactive systems that enable people to be more efficient in their daily lives. The title of his talk is Towards Extensions of the Self, Near-Body Interaction for Augmented Humans, which is going to be about research projects that tackles the challenges like limited out and input capabilities, proximity of interaction, and obtrusiveness and privacy. So the talk will be about an hour, and then later on we will have a brief Q&A session about 30 minutes. Without further ado, over to you, Enrico.
Yeah, thank you, Yun, for the very kind introduction and the invitation. I'm really happy to be here today, and it's also fantastic to give a talk on 2 different days at the same time. The talk is going to focus on basically on our research on wearable computing. It's entitled with Towards Extensions of the Self, Near-Body Interactions for Augmented Humans. And Yun also asked me to speak a little bit about our group in Ulm, and I will do that in the first 10 to 15 minutes. And later on, I'm going to focus then on our research on wearable computing. And Yun and I just looked at this picture from 2018 when we were able to meet each other physically, and there was this nice Shonan meeting in Japan on AR and HCI, which was quite interesting in terms of the exchanges we had. So you see Yun here on the right hand side smiling, that's me. There's Teresa, who's also participating today, and kind of reminded me. So this invitation from Yun kind of reminded me of that meeting because we met there for the first time. I would like to say a few words about Ulm as well, because it might be not that well known in New Zealand or Australia where it is. So there's a map of Western Europe. You have London here, you have Paris here, you have Berlin, and basically in the middle between Stuttgart and Munich, you have Ulm, which is a rather small but historical city. And if you want to remember 2 things about Ulm, then you can remember that's the birthplace of Albert Einstein, and you can find the highest church steeple in the world there if you visit us. When it comes to the university, then one could say that it's a rather smallish and new university. If you are looking for highlights, you could remember that it's the highest situated university in Germany because it's located on the top of a hill. It's probably also the highest located university within the European Union, but we are not sure about that. Despite its small size, it has a relatively large computing and engineering department, and we're really happy to have a relatively large number of students studying there. And another interesting aspect is that we are probably in the region in Germany where you have the lowest unemployment rate, which is quite beneficial for our students because they get kind of very nice jobs afterwards. One aspect which is really special about Ulm University is the science park concept. So when it was funded 50 years ago, they had this science park concept in mind from the very beginning on. It's basically the idea of having the university co-located with companies. Yeah, and if you visit us in Ulm, you will see that you find like Daimler, BMW, and so on on campus, which is fantastic for our students because many of them work there part-time. It's fantastic for them when they leave university because they find fantastic jobs there. But also for our research, or for me as a professor, it's fantastic because we have lots of collaborations with them, and that's a quite kind of bi-directional and positive collaboration. Yeah, so within the university, I had the HCI group, which is within the computing department, within the Institute of Media Informatics, and as you know, is HCI a very important field within computer science. And I started to work within the field, like, I don't know, 20 years ago, and I'm still amazed by its importance. And here those little kind of examples show also the importance of that, yeah, because you see basically there are kind of trends from kind of certain technology to other technologies, and if the companies can't follow those trends or can't set those trends, then they lose basically their relevance. Yeah, one prominent example is Nokia. They had a market share of 50% in smartphone sales around, I don't know, 15 years ago, and now they are not relevant in terms of being a mobile phone manufacturer, and a company which never ever made a phone beforehand is now kind of leading the market. Similar, the instant messengers you see in the middle. Yeah, I think when I was a student or a PhD student, everybody used ICQ on their machines. But nowadays, nobody's using ICQ on their phones, which is kind of interesting. That again, because they were dominating the market, the same with Skype, but they weren't able to foresee the trend towards like smartphones. And now everybody's using, I don't know, Facebook Messenger or WhatsApp instead of ICQ on their phones. And it's interesting. Yeah? Why weren't they able to? Why wasn't ICQ able to foresee this? Yeah? Would have been simple in terms of technical migration, but they didn't follow the what the users actually wanted and what they desired. And the same with the example on the right-hand side. So the market for, I don't know, music players or players of fairy tales was dominated by CD players up until, I don't know, 5 years ago. And there was no commercial interest there, yeah, because we were able to buy a CD player in a supermarket for $30. Yeah, and then the company, which is quite well known in Germany, Tony's, you can buy it also like in the UK, maybe Australia as well. They developed a music player for children, which is basically this box, and you start the music by putting the mouse on the box, or you start or maybe the mouse represents a song, or like the tail of the mouse, something like that. So it's starting it is quite easy. You place the mouse on top of it and you control it by boxing the box or by touching those little ears you see. And with that, very young children can play its own music and stop it and pause it and so on. And from a technology point of view, this is kind of trivial to implement, yeah. But in terms of interaction design, this is fantastic. Yeah? And like 5 years ago, everybody thought the market is dead, but with the Tony's box, you kind of established a new market, and this is only based on the right user experience design, not on technology advancements. And that's something which really fascinates me, that we constantly see those kind of new trends emerging. And it's also interesting that sometimes the dominant market players can't follow those trends or can't set those trends. And that shows me how important it is to look at the user as much as possible. And that's something we try to do as well in our research group, not from a commercial perspective, but from a scientific perspective. And the research methodology we have is similar to most other groups. So we look at problems in terms of interaction and try to find solutions for that. But we are also very much driven, that might be different to other labs, driven by opportunities. So we are very often looking at new devices, new displays, new sensors, and so on, and try to figure out how they could be used to make something better, yeah? Like in terms of interaction also, and so on and so on. And based on such a problem or such an opportunity, we develop kind of new interaction or device concepts. Then very often we try to build interactive systems as well. Like at the bottom, you see like an interactive avatar for a car, a mobile wearable device which can emit sense. Then a device Jan was building, who is kind of participating here, like it's an VR device with displays facing kind of the outside, or like a car which has a display for pedestrians. Yeah, so developing interactive systems in terms of software and hardware, that's something we do quite intensively. And if you're looking for something which sets us apart from other groups, then it's likely this kind of focus on building systems. And then, like other groups, we evaluate systems in the lab or in the field. And here I have an example of such an exploration. It's just switching to the video transmission mode. It's a student project we did in, I don't know, 2014. It's something which was never ever published, It's basically used at that time the first Oculus device, which was available then, and added 2 cameras to it and developed a video see-through AR device. That's something I think 10 other groups did at the same time. And it was nothing we used for publications. It was more like a research vehicle. Yeah? So we played with it, and we saw that, okay, at that time it was very tricky to track hand or finger gestures. So we had to use the fist for like interactions. And we also saw that using fist-based interactions is socially not acceptable, yeah, in public settings. And also in terms of marker tracking, and in terms of where you display things, whether it's in the center or on the side. So this kind of was something which didn't help us in terms of publications, but helped us in terms of what could be done or what should be done in terms of interaction design for computerized eyewear. Yeah? And this led then also to that leads often, this kind of philosophy leads often to kind of interesting hardware prototypes, which is then also often covered by the media. And here there's this article from the IEEE Spectrum, which kind of featured then 2 of our projects. And that was nothing we were ashamed of. It's just part of our research philosophy. And if you try what is bizarre things, it's the term which is used here, then often you kind of come to new kind of conclusions you wouldn't have without building such systems. In terms of the research areas we cover, there are different ones. One field which is quite strong in my group is automotive user interfaces, or interactive production planning for building cars. So we do a lot of research on driver-vehicle interaction, and also interaction between autonomous cars and pedestrians or cyclists and so on. And there we do kind of, again, prototypes on various scales. In a driving simulator, we have self-driving cars on campus, which we can augment. Or here on the left top, you have a car with an external display for communication with pedestrians. I'm not going to talk about that today. This research trend is quite common for German universities, which are located in the south, because you have basically all the large car manufacturers nearby. So there's again a map of the south of Germany, and you have Ulm there, and basically we have nearby the headquarters of BMW, Audi, Mercedes, Daimler, or Porsche, and all the kind of suppliers are also kind of nearby, and that's why a lot of kind of industrial research labs are nearby, and we have kind of collaborations with almost all of them on some level. Yeah, and that's quite fantastic to have those close industrial ties, and that's also if I have to think about my most influential kind of research projects, then it's probably in this area, but often they are not published or not well published, because the commercial interests are stronger here and are favored when compared with academic publications. Another research strand was presented 2 weeks ago by Jan Guggenheimer, who left my group 1.5 years ago, and who kind of established this research area within my group. It's called, he calls it ubiquitous mixed reality. I won't talk about that today, but it's about using VR technology, for instance, for co-located collaboration, it's about interacting with VR, also about altering what you see using AR devices. Other research strands I'm not going to talk about today, which are covered in my group, is personal fabrication, again supported by AR technology. It's about how you could use also various technology to improve our lifestyle, or how to keep us healthy in a certain way. Tobias, he's kind of depicted on the bottom right. He's kind of looking into how to author kind of 3D content or interactive 3D content for virtual reality. And Teresa, who is also here, she looks at digital eye strain in computerized eyewear. So these are that's an overview of the things I won't cover today. And if you're now interested in Ulm at Ulm University or in the research we're doing, I would just like to say that basically everybody's welcome to visit us. And if you are kind of interested to stay for longer in Ulm, for like a month or 3 months or longer, obviously we always welcome other researchers. And something which I would like to mention here is the German Academic Exchange Service. So it's quite relatively easy to get like a research grant for such a stay, which covers usually all the expenses. The only tricky thing is to fill all the forms correctly in and to tick all the boxes. But once this has been achieved and we can help with that, it's extremely likely to get such a grant. Yeah, hopefully we can visit us again physically again after COVID, and that's an interesting opportunity here. Good. Now I would like to come back to the actual research talk, which is on our research on wearable computing. And this research focuses also on the way how we see computers. Yeah? And very often computers are seen as tools, yeah? But I would like to see them rather as means which augment us in a certain way. Yeah? And this tool perspective is something I think most people have in mind when they think about kind of HMDs and mobile phones and so on. But I would like to see more technology which actually augments us, and that's actually something computer science had always in mind. Yeah, and if you look at those kind of at the first papers in the field, then they are not that much about tools. They're also about this augmentation aspect. Yeah, and one article you're all aware of is this As We May Think article, which was written by Vannevar Bush at the end of the Second World War, where he kind of described this vision of how computing looks like. And he kind of designed then this MEMEX device. And he saw it not as a tool, but as an enlarged supplement to our memory. Yeah, it's quite interesting, this perspective. And Douglas Engelbart, the founding father of HCI, he also had like a similar perspective on that. Yes, his system was about augmenting us, about augmenting our human intellect, and it's about increasing our capabilities to approach complex problems, to gain comprehension, and so on and so on. Yeah, it's kind of interesting to see that, yeah, in hindsight. And something which helps us with this perspective as well are those little drawings from Rekimoto and Nagao, which are kind of, I don't know, 25 years old. And there's this nice paper, they kind of depict the different interaction styles. And I just want to show 3 of them. So the one is where we don't use a computer. So it's just us and the real world, and we are interacting with the real world. And the situation we have nowadays, I don't know, 95% of our use cases is the situation we see here in the middle. So it's us interacting with the real world, yeah, and us interacting with the computer at the same time. So we are somewhere with our phone or our laptop or whatever technology, and the things we do with the phone or the laptop very often have nothing to do with the location we are in. Yeah, and this gap is really, really strange, yeah, because that's not true for most of the other tools we use in the kitchen or in the garage or so and so on. And it's something we just got used to, yeah, over the last, I don't know, 50 years. And the idea behind wearable computing is obviously to change that. The idea here is that you are still able to interact with the real world, but there's some kind of mediator, yeah? Which is whatever wearable computing device. And then the question is, when does a wearable computing device become like an augmentation of us and isn't seen as a tool anymore? And there are many criteria. I will show them also later on. But I think I would say that the most important criteria, the main goal is kind of a time. Yeah? And this is again something which was depicted by various kind of influential kind of founding fathers in our field. It's basically the time between intention and having the result. Yeah? And this is also something which Alan Kay, the kind of the founding father of, I don't know, tablets, described in the 70s with his Dynabook concept. And he kind of also spoke about the time between, wanting something and having something. And he kind of used this metaphor of a flute. Yeah, so he said, okay, there should be no pause between cause and effect, and when using such a system, this should be like a flute. Yeah, so that there's no difference, there's no thinking about what to do. It's just something you use and becomes part of yourself, like playing the flute or riding a bike or something like that. And the same idea was again described nicely by Ted Starner in a really kind of cool article. Suggest to read that. It's called An Extension of the Self. And there he said, it's kind of nicely expressed, when the time between intention and action becomes small enough, then the interface becomes an extension of the self. Yeah? So if we reduce this time difference from, like, I don't know, nowadays, if you want to do something with your smartphone, this maybe takes like 20 seconds to get the result. Yeah. But if this gets down to like 2 seconds, that's the duration he mentions in the article, then this becomes part of yourself. And what happens if it's like 1 second or like 500 milliseconds? And this seems to be kind of interesting, but it's actually something we try to achieve since decades. Yeah, because obviously we are moving towards kind of more mobile or more wearable devices in order to reduce access time, basically. Yeah. Interestingly, like the desktop computer disappeared, yeah, but on the other side, like laptops don't disappear right now, because we basically get smaller and more wearable devices, yeah, but their kind of interaction power is kind of limited. Yeah, you wouldn't write your PhD thesis on a smartwatch. Yeah, you still would rely on your laptop computer. And the question is, what has to be done so that you write your, I don't know, PhD thesis on smart glasses. Yeah? So there's kind of, there we will see how it goes. Yeah, so it's getting more mobile, but the question is also, can we move kind of complex tasks also towards the right top? Good, and obviously when it comes to wearable computing, there are lots of developments out there in terms of products and cool research papers and so on and so on. And now we could say, okay, this is going to continue, and that's just going to happen, and we only have to commercialize things. Yeah, and there are examples which are extremely successful in terms of commercial success, but as I said, they are kind of often limited to certain application areas. Yeah. And if you look at kind of more complex use cases, then very often you kind of instantly see kind of limitations of the technology. Yeah? And I have one personal example where I kind of constantly think about wearable computing. This is kind of mountain hiking, so Ulm is very closely, it's very close to the Alps. I've spent a lot of time in the mountains. And that's kind of a nice application scenario for wearable computing, actually, because when being on the mountains, you basically have to climb. You have to pay attention that you not fall kind of somewhere. And very often you use hiking poles, so your hands are occupied. And the information leads, especially when you lead a group, it's kind of quite complex. Yeah, you have to know where you are. You have to know where you're going. Yeah? If you don't do this right, people might get hurt or might, die in an extreme case. You have to pay attention to the time, the weather. This is also kind of very crucial. You have to communicate internally and externally. You have to entertain the group. You have to know which peak belongs to which mountain. You would like to take photos and be active on social media. Yeah? And I tried a lot of technologies around that, but at the end it's always a mixture of smartwatch, smartphone, not AR glasses, paper maps. Some people have GPS devices, a watch, and so on. And it's just not satisfying what we have there in terms of wearable computing technology. Yeah, that's kind of, if you think about similar cases like manufacturing or assembling cars and so on, then you kind of see similar challenges. Yeah, there are no kind of perfect solutions out there for everything. And something where you see this as well is this kind of really nice article by Steve Mann. That's basically based on the keynote, the keynote of during the first ISWC conference, the Wearable Computing Conference he gave in 1998, and there he defined the 6 attributes of wearable computing, yeah, which could be also renamed into 6 challenges of wearable computing. And some devices we might have provide solutions for some of them, yeah, but not all of them. And if so, then only in limited usage contexts. Yeah. So again, what are these 6 attributes? So these wearable devices shouldn't monopolize our attention. So we should be able to still see the environment, be able to hold our walking sticks. We shouldn't be detached. They should be unrestrictive. So should be able to do other things. They should be observable all the time. They should be able to see information. They should be controllable all the time. They should be attentive to the environment, and you should still be able to communicate with others. Yeah, and I think there's still a lot of research to do to kind of solve all those kind of challenges in the future. And that's where we try to provide solutions as well. And the research frame for the work we do in wearable computing is this one. It's again, you see the timeline here. And what we see here is basically that the input space you have with your device is becoming smaller and smaller, yeah, from like a, I don't know, large desktop machine to like a phone, a smartwatch, and it might get larger once we have kind of a wearable or computerized eyewear. Yeah, so that's the goal. That's not a goal. That's what was happening in order to have them as mobile or wearable devices. And we do that because we want to reduce access time, basically. Yeah, we don't want to spend 60 seconds to look for the weather. We just want to spend 2 seconds to get this information. Yeah? And one downside, actually, when having wearable computing devices, are those concerns in terms of obtrusiveness and privacy. Yeah, if you think again about the Google Glass concept, this was kind of very interesting from a hardware perspective. And I guess one of the main reasons why it wasn't successful were the concerns in terms of obtrusiveness and privacy. Yeah, people they didn't dare to use it in public. They didn't dare to speak with it in public, and so on and so on. But on the other hand, we have also this advantage that those devices are very close to our skin, and close to our eyes, and we could leverage that. Yeah? And in that, when it comes to those kind of 3 lines, we do kind of research which tackles those issues. And I would like to.
Es sieht so aus, als hätte ich dich nicht richtig gehört.
That was my
Bitte versuche es erneut.
That was my Alexa kicking in. Or I didn't say the keyword. Sorry. So this kind of shows the trends we are seeing and the potentials and the issues we have. And the area I would like to start with is a kind of input and output space, and then I'm going to move to proximity to human sensors, and then to obtrusiveness and privacy. And I would like to speak about those 7 projects we did in this area. So first, one of my older projects, it's called the Ambient Mobile Pervasive Display. It's something we did, I don't know, 7 years ago. And that was a time when my group didn't look at AR or VR devices at all, yeah, because it was the time before the first Oculus was released. And Christian and I then believed in wearable projectors and many others as well. And there was this vision that that wearable projectors become smaller and smaller and more powerful and more powerful. And there was a trend towards using them for various use cases. And Christian then thought about kind of this ambient mobile pervasive display, which is kind of still very interesting from a conceptual point of view. Yeah, so he had this idea of that you have like a wearable projector. In the morning, you clip it to your belt or to your bag, and it kind of is always on and is always projecting information in front of you. Yeah, it can be used for navigation, to see nearby points of interest. It could be used for advertising. It could be used for location-based messages, and so on and so on. And it's quite interesting. And you might now think that, okay, this wearable projection idea is kind of outdated. We could say yes, that's right. But interesting point is that all those concepts could be replaced by AR devices, like, I don't know, the Microsoft HoloLens plus. And then from that perspective, those interactions still make sense. The metaphors I'm going to show you now. So something we looked at was how could you interact with such device? The first important aspect, it's an ambient display. That's quite important. So it's not overwriting your whole visual perception. It's just the floor which is being used. And that's a metaphor one could use again for AR devices. So you could place information on the outside of the visual field or on demand, or you could just display it on the floor as a metaphor. And then Christian thought about how could you visualize certain information. And then he had also this idea of picking the information up. You will see it in a minute from the floor. You use your hands to move the information from the floor to your hands. Then you could use the orientation of your hands to kind of control certain aspects. And he had also really nice metaphors that if you pick something up with your hand, you could throw it over your shoulder, so it's being deleted. It's quite rich in terms of the interaction concepts, what he thought of at that time. Again, it was important to build such a system, or to experience how the device could be used and how the interaction works, and so on and so on. And at that time, the challenges were similar to the ones we had at that time with like VR devices. It was, for instance, hand tracking, which was quite challenging. Then also the autofocus was challenging, which isn't the case when thinking about today's AR or VR devices. And I'm going to play the video in a second. I'm just optimizing the transmission for that. And that's the system we had.
Mobile pervasive display the user carries.
So you see a Christian walking around with the system is slightly larger than in the concept drawings. You see it had also certain limitations in the projection width or the field of view. But in terms of interaction, it's something you could still kind of like when thinking about VR devices. Information could be displayed on the floor still, and you could use your hands as a mean for interacting with information. You could pick it up. You could use your hands as a means for interaction, and also the metaphors are quite interesting to throw it away. And also the use cases we had then is again use cases you could easily copy to like VR devices. One aspect we focus a lot on then were kind of location-based information dropping and picking them up later on. So we had this notion of that information belonged to a certain location. You take a picture at a certain location, you drop it there. There's an elevator interface like 20 meters away from the elevator. Not sure how this could transfer to AR devices nowadays, but there was always this notion of having the information when walking to a certain location. And something which I also like in terms of the navigation is that the information is displayed on the floor. So you could think about using today's AR devices. And the question is, where do you display the navigation information? Is it somewhere in front of you, which might be helpful, but also disturbing? Or is it on the pavement in front of you? It's kind of still interesting to look at it like after 8 years. Another project which was conceptually very rich, but was actually not that well published. It's the Snapband concept. So when you think about interacting with computerized eyewear, with smartwatches and so on, obviously the input capabilities are kind of limited, or challenging to say. And one toy kind of which triggered this concept is the Snapband toy. You might know, you probably had it as a kid. It's basically a Snapband, and it could be flat, or you could attach it to your hand, to your wrist, to your bicycle, to a bag, and so on. And the idea is that this is kind of touch sensitive. It's a touch sensor, and you could attach it to any of the objects you have in mind, and you turn that into like an interactive surface. And with that, you control your AR device or your smartwatch or something like that. And that's something I still find very interesting from a conceptual point of view, that you have that that you have like maybe an output device and an input device, and you can attach this input device to whatever kind of part of the body, or your bicycle, or I don't know, something else. Yeah, it's kind of interesting. It's something we didn't pursue afterwards after publishing it this week, but it's kind of something I still like. And here you see the prototype. It's basically based on capacitive sensing, and it had kind of, I don't know, 2 to 8 kind of 2 by 8 touch sensitive areas, and it actually worked. Yeah, but it's nothing we pursued then further. Another project which looked at how to address the input capabilities is this pocket thumb concept, something David, one of my PhD students, did a while ago. And he kind of thought a lot about access time, yeah, something I mentioned beforehand. So access time is really, really crucial, yeah, because if you think about, I know, checking the weather or checking the news or checking WhatsApp messages, that's something you wouldn't do if it would take, I don't know, 30 seconds to 60 seconds. You do it only because it only costs you like 10 seconds to access it on your smartwatch. Yeah. And when you think about, I don't know, again, interacting with computerized eyewear, the question is, how do you interact with it? Is it kind of voice? Is it speech-based interaction? Is it kind of touching it? Is it using controllers? All those means are kind of not feasible when walking, you know, while being in the subway or something like that. So access time is important, and something he sort of was using your trousers of your the pockets of your trousers as a means for input. Yeah, because if you wear trousers, they're always there, the pockets, and the access time is, I don't know, is like a second to touch it. And something which is quite interesting, which we only figured out because we did it, was kind of hand stabilization. So your hands, or your hand rests on the trouser pocket, and this actually heavily this stabilizes your hand while you're walking. It's kind of, we see this later on, that you can provide really accurate input while walking, and it's actually also socially accepted to do that, because most people wouldn't recognize that you're interacting with your trouser pocket, because it's something you could have your hands there anyway. Yeah. The video I'm going to show you shows kind of how it looked like. Again, switching to video transmission mode. That's David using the system. So it could be used to control kind of, I don't know, a smartwatch or like any kind of computerized eyewear. Here he controlled the Google Glass. And something which is kind of trivial in hindsight, what was very important for us was this dual-sided interaction. Yeah? If you think about the touch screen, you interact with it only from one side. And here we had this opportunity to interact with it from both sides. Yeah? And this helped first to stabilize the hands. And most of the interaction techniques David came up based on this concept of being able to touch them from both sides. So first he looked at kind of accuracy and speed. Yeah. So first he kind of looked at this dual side concept. So you use your thumb for kind of localizing the pointer and your index finger for selections. And then he compared it with like single-sided interactions. That's what you do when you use your phone or smartwatch. You only use one side, yeah? Which is kind of true. And then he compared this like one-sided relative input and one-sided absolute input with like this dual-sided input concept. Interestingly, then in terms of performance, this kind of dual-sided approach was better in any regard he measured in terms of selection time and error rate, yeah? Because basically you can use both sides, you can rest your hands while walking. So that was quite beneficial. And I think one of the most intriguing aspects is this trivial aspect that you can use the fabric from both sides. And this was also the basis then for many interaction techniques he came up with. One is kind of spatial tapping. It's basically resembling a mouse with like a left and right mouse button. Again, he used the thumb for like localizing, and then using the left or right finger for like a left and right mouse click. Yeah, that's something we know obviously from using a mouse, but that's something we I guess, often miss when using kind of a touch screen, yeah, or like the touchpad on your laptop, or a touch screen on your smartphone. And I just show you kind of two examples. There's a longer video online which showed many kind of usage scenarios which are based on this concept of using the capacitive sensor, where you kind of can touch both sides. I mentioned this now, like I think the 10th time, but it's something which is in hindsight trivial, yeah, but hasn't been done before, and it's only something we figured out because we've actually built the system. Yeah? And this again stresses the importance of building something to figure things out, which might sound trivial in hindsight, but maybe of people, so nothing people thought of beforehand. Good. With that, I would like to leave the kind of input and output space issues, and would like to focus now on the proximity to human sensors. So that's actually an advantage of wearable computing devices. So they're close to our skin, our eyes, and so on. And a project Dennis worked on is this face-on concept, basically using computerized eyewear like VR devices here, and use this to provide, beside visual and auditory output, sorry. So besides visual and auditory output, he provided also tactile input, which had a very high resolution. You see all the tactile actuators here. There were actually many of them, yeah? And they actually are touching your skin. And then he used PT elements to heat the contact area up or to cool it down, yeah? Which is kind of different from what others did in terms of having this higher resolution, and also in terms of combining this with the other modalities. Yeah? And he kind of did a nice user study, which was based on the video I'm going to show you in a second. The video is basically based on a train, is a train ride, and you're sitting on top of the train. And here you're going through a tunnel. And the first situation is where those bats are flying towards to you. There the temperature keeps the same, but beside the auditory information, there's a tactile wave pattern, yeah, going from the center of your face towards the side area of your face. And if you're visiting us, this is something you should try. It's really impressive to see the visual information, the auditory information, and then this pattern, this high resolution pattern on your face is quite impressive. The most interesting aspect or effect, sorry, is the one you are going to see in a second. There are sprinklers on top of the tunnel. There's the first one. And now we're going to see the second one in a second. And here, again, you have the visual information. The video is lagging a bit. You have the visual information, auditory information. And here, then is used kind of a random and frequent activation of the tactile actuators. Yeah, it was kind of tickling on your face. In addition to that, the PT elements became cold. And this is kind of a really interesting, and that triggered a really interesting effect, which was described in literature beforehand. Your face feels wet. And this is really, really amazing if you try it. So it really feels like there's actually water dropping on your face. And this is, again, an example of this kind of combination of visual, auditory, tactile, and thermal information. And if all this comes together in a nice or ideal combination, it could generate really, really interesting effects. Yeah, similarly here, you're sitting again on the train. The train is driving. It's cold out there, so the PT elements become cold. And there are kind of, again, light tactile activations on your skin. And again, it feels like there's snow kind of dropping on your face. Here there's now an avalanche coming from the top of the mountain. It's again cold. And now kind of all the kind of actuators go on in an intensive burst, and it again feels like that the snow is kind of heavily hitting your face. Yeah, then we have the last scene where kind of it's warmer, yeah, and there's a kind of a chat kind of attacking you, and you have again those tactile patterns on your on your face, and it kind of goes into that direction. It actually feels like something is shooting at you. And then there's a last effect where there's an explosion, and here there's again a combination of a tactile burst around your face and a heat sensation created by the PLT elements. Yeah? And that's kind of a really nice project. He also kind of did a study then and showed that the enjoyment and presence increased because of those patterns. There's some things you can't see it in the study. It's really that's a system you should actually try, because it's so impressive how this kind of tactile sensations feel. Yeah, and you could easily imagine that this might be included in future products. Yeah, there's no reason except costs which prevents this. Yeah, but this could be the case here. Here's a system we looked at. Again, we leveraged the proximity of wearable computing device, VR device in this case, to our human senses, in this case to our skin. And here we used tactile sensations created by airflows to create the immersion or create the illusion of wind blowing towards your face. Yeah? Going to show you the interesting hardware first before talking about the illusions you had. Yeah, that's a system which was built. It was a student project, a master students project, and this basically through those kind of so it basically blows air onto your face, and you can control this quite easily through those arcs, which can change their orientation. There are two arcs, so you can cover the whole kind of area around your head, and it has different nozzles, and you can switch them on and off, and you can change the intensity, yeah, of the wind, and you can basically say through that you can say, okay, there's I know the wind source kind of going over your head, and this is kind of then realized through those kind of bows and nozzles which are being switched on and off, or the arcs changing their direction. Yeah, you see it again, how it looked like. This is something which is probably tricky to commercialize, yeah, because it's quite large in terms of the physical footprint. But again, we use this as a research vehicle. Yeah, so if you want to commercialize this might look different than this one. But our aim was more to look at how this could kind of increase enjoyment and presence, yeah, with various scenes. So one scene was, for instance, was at a cliff. We were standing at near the beach, and there's a sea, and the wind was coming towards your face. And when you turned your head, then the wind was not coming from the front anymore, but was coming from the side. Yeah. Or there was another situation where you were driving with a golf cart, and there was wind coming from the front, and then there were bats flying over you. So there were situations where wind or plays a role, and all those kind of wind illusions were kind of generated with this device. And the study again spoke for such an approach. That's again an example that you could actually have a benefit from having those devices that close to our human sensors and actuators. Good, and that's another project which benefits from this closeness. That's maybe even more far-fetched than the previous one. This looks at the idea of having kind of movable wearable computing devices, and you might be aware of other works which looked at kind of little robots moving around your clothes and so on. But here we had this idea that you have something like a smartwatch here, and a smartwatch is not just it's not just being able to provide kind of visual or auditory information or maybe tactile sensations, but the idea is that the device could actually move, yeah, could change its location from being here, or could move up my arm, for instance. Yeah, that's something I think the students, it was again a student project, the students thought of. And again, they developed a prototype where we knew, okay, this won't be the first step towards the final product, but it's something, again, we were able to use as a research vehicle, as something like an object to think with, yeah, to imagine how such a possible device could be used in the future. And I'm going to show you the video in a second. It's here, and switching to the video transmission mode. So again, the vision, it's not about such a large device as here, yeah, but that's actually what the students built. It's actually a device which can kind of move along your arm, yeah, without hurting it. And then it was first quite challenging for the students to build it, yeah, because there are different arm sizes and widths, and you might have hairy arms or not, and so on. So it was quite tricky. But then it was something we were able to use for studies. So the one question was, how accurately can you locate it, yeah, on your arm? And then it was something which triggered potential future use cases. Yeah? You see this here, so it could kind of show progress. Yeah? So if you download something, the temporal distance to like the lunch break, or spatial distance while kind of doing mobile navigation, and so on and so on. Yeah, it's kind of one of our projects I really like. Interesting prototype, and again, like some of the others, something you probably won't find something similar somewhere being published. Yeah, and it's again something which shows our fun with like building systems. Good, and then the last area which is we look at, which is also quite important, is this obtrusiveness and privacy aspect. So that's one issue which is very often neglected. So we think about kind of fancy AR devices, but very often it's not acceptable, yeah, to use them in public because you can't speak with them. It's kind of awkward if you perform mid-air gestures at a bus stop, and so on and so on. And that's something, again, David looked at a few years ago, and he was the one who kind of thought about this interaction with the trouser pockets as well. And something he sort of as well was using your belt, in case you wear one, and using you to use this as an interaction device. Yeah. And basically the vision is that if you have a belt, that the whole belt is again touch sensitive. Yeah, it recognizes where you are touching it. And that was the idea. And then David and Philip built a system which was quite challenging to have it in such a small form factor, to be it actually wearable. And then it was again something he used to conduct user studies. I'm going to show you the system in a second. And in the beginning, this obtrusiveness is shown, and hopefully you don't see David interacting. Hopefully it's nicely disguised or hidden. Again, switching to the video transmission optimization mode, how that's called. And that's the belt system now. So it's David interacting with it. So the glasses are nicely hidden. And obviously the belt is not fashionable, yeah? But it's again something we use as a research vehicle. So basically every of those knobs is touch sensitive. Was really challenging to have it in that small form factor, so it could be used in a user study, and that was then used to figure out how it would be used. And I'm going to stop it in a second. And one important aspect, or something, one of the key insights were kind of shortcuts, so that you kind of connect certain locations around your body with like certain applications. So for instance, the area where you might have your wallet as a man if you wear trousers, that's where the wallet application might be located. Yeah, or if you touch your side, then it's maybe the navigation application or something like that. Yeah, so people were interested in using certain locations of the belt to trigger the start of certain applications, yeah? Which is also here shown in the video, like wallet or contacts and so on, a music player. And here you see also, sorry, where the idea for the back in a second. And here also see where the idea for the kind of interaction with the browser pocket comes from, because here people also said, okay, if that's something I could use as an unobtrusive interaction. I might have my hands in my browser pockets and might use the thumb for like swipe gestures, something like that. And again, it's also like beneficial in terms of access time, yeah, because you can use it while walking, yeah, while doing other things, like while looking at the AR glasses or while talking with somebody else. Yeah? And obviously, we have kind of a more convenient design in mind when it comes to the belt interaction concept. The last project I would like to talk about today is the Incent project. I would say it's the first kind of wearable olfactory display we've built a few years ago. And it again uses the proximity to the human sensors, yeah, the proximity to our nose. But it's also a device which could be used as an unobtrusive means for communicating information. It's also, to some regard, a private device, because only you might be able to smell a certain scent being emitted by the device. You see here on the right-hand side how it looks like. It's rather small, yeah, and we're quite proud about the small form factor we have, and it's also it's really mobile, truly mobile. And we were inspired by other projects which looked at kind of olfactory displays which weren't mobile and which weren't probably socially acceptable. Yeah, and we had this idea in mind that you might wear something like this, like a pendant, yeah, like a piece of jewelry around your neck, or you might clip it to your clothes, and it kind of emits different kinds of scents. Yeah, it might be coupled with your phone. And when my wife would send me a message, I would get kind of a pleasant smell, yeah. And then I would look at my phone and see her message. Or if there would be like an important meeting coming up, I would kind of experience a very strong scent, which reminds me, oh, now this meeting is going to start, I have to be there. Yeah. That's switching back to the video mode. Sorry for that. That's how we imagine the usage of the device. So I might have a user like her, and she smells something, and then she's checking the phone because of the smell she experienced. Yeah, that's how we envision the usage scenario. And here you see kind of an illustration of how it actually worked. I'm going to play it. Hopefully you see it in Australia. So we visualized it. It's basically, if you would put it in simple terms, it's an wearable electronic cigarette with different scents, and it's basically Bluetooth controlled. Yeah, that's the idea behind it, and it's also how it works. So you see the inner workings of the device. Something which is really beneficial is that we have several scent chambers in here. I think there are 8 of them. And if in that you have kind of essential oil mixed with highly viscous carrier liquids, so it's a little bit sticky, the scent in there, so it doesn't flow out of the scent chamber. And it's basically, you have little kind of wires in there which heat up once you put current on them. And then it's basically vaporized. Yeah, and that's something you can control. You can control when it's being heat it up, and for how long, and how much voltage you put on. And then on top of the lid, there's a little fan, and this little fan blows the sand towards your nose, as it's shown on the right-hand side here. Yeah. Again, we are kind of always kind of interested in building interactive systems, and that's kind of a really nice example of a prototype which we developed. So everything was developed by us: the casing, the sand chambers, the copper wires in there. The circuit board was developed by us. The battery was obviously something which we bought, and it went through several iterations till we were happy with the system. Yeah, and till it could be used for user studies, which we did as well. So the study consisted of participants using the device, and they had to use it on campus. That was obviously before COVID. And they had to perform tasks like ordering something in the cafeteria, using the elevator, and so on. And then beforehand, they kind of assigned certain scents with like certain kind of messages, and we released those scents during the study, and asked them also. It was kind of more like a qualitative, informal study, and so that the participants were able to envision how they could use it later on. And one kind of key usage would be, or probably then in future, so if something like this is commercialized, personalized events. You connect a certain scent with like your, I don't know, your partner, your mother-in-law, and so on. And you could say, okay, if there's a meeting coming up, then I will smell this, and so on and so on. So people were very keen on like defining rules. If this is going to happen, then I want to smell this. Yeah. Also, to remind me, and so on and so on. Something which we didn't sort of before developing the system, but again, in hindsight, it's obvious, is kind of smell pollution, and the question whether bystanders will smell it as well, which could be pleasant. Yeah, if it's a pleasant smell and you're on an elevator and you start to appear kind of in a better light because you smell better. But if you have kind of an awkward smell being emitted while being in an elevator, that's not beneficial. It was seen as a very subtle and non-disturbing means for communication. Yeah, because like if your phone is ringing or it's vibrating heavily, then this might be disturbing. And this emission of a scent, this was kind of seen as non-disrupting. Yeah, it's kind of, there's a light scent coming towards my nose. I know, okay, there's a message from my wife, and I might check my phone or not. Yeah, that was seen as quite positive. Reliability was seen as something challenging, because if you are running, then obviously the wind kind of blows the scent away. This was seen as an issue. And again, they kind of suggested to combine it maybe with visual and kind of information, or with tactile information, or with auditory information. Yeah, it was again kind of an interesting, interesting and novel concept. We've built it and kind of looked at how it could be used in the future. And with that, I'm at the end of the presentation of the research projects we do in wearable computing. The question is, what is next for us? Something we are intensively looking at, especially Teresa and others, is kind of using kind of eye-based interactions, because nowadays you could easily buy glasses like the ones Yun and I are wearing, and you could include an eye tracker in that. And the question is, what could it be used for? Yeah, in terms of interaction, in terms of activity tracking, and so on and so on. Wearable fabrication is something we're looking at. So you have kind of stationary fabrication, mobile fabrication, but what happens if you have like, if you're always able to fabricate something while being on the go? Another area Gabriel is looking at, one of my PhD students is augmented hearing. That's actually a strand of wearable computing which is quite successful in terms of commercial business cases, also when it comes to hearing aids, but when it comes to interact with them or using them for kind of augmentations or altering your sound environment and so on, there's actually not much out there. So it's a kind of underrepresented area within wearable computing. That's something we are looking at Just imagine this would be your only kind of computing device and you have nothing else. How would you interact with it? How could it alter your auditory environment and so on? And something I'm currently most interested in is looking at how you could sense and model our attention, perception, and cognition, because my background is rather on the technical side, and we kind of often focus on like kind of engineering aspects and making things maybe faster and less error prone, and other aspects I mentioned today. But very often in the past we ignored those kind of human factors or psychology aspects stemming from psychology, and that's something I would like to focus more on in the future. Yeah, and let's see what we're going to do in those 4 areas in the next years, beside the other research topics I mentioned in the very beginning of my talk. And that's the end of it. And I'm open for questions.
Thank you very much for the amazing presentation, Enrico. So are there any questions from the participants? If there are, feel free to type down on chat, or you could just raise your hand and just ask your questions.
I have a question.
Yes, Mark.
Okay. Thanks for the presentation. That was really, really nice. Just a more general question. So you've shown a wide range of projects that involve interesting integration with hardware and software, a lot of focusing on wearability. So how do you get inspiration for these projects? If you're giving advice to students about what they should be thinking about for their PhDs, I'm really curious about how you get inspired for some of the work and what makes you decide on certain projects versus other projects.
That's a really good question, and I probably don't have a simple answer to that. So one of the key challenges when doing a PhD or before when starting a PhD is to look for kind of new research questions and new opportunities out there. And it's quite challenging because very often you look on the ACM Digital Library and you might have an idea and you find that it has been done beforehand. Not sure about, so what we do in our group, we are kind of like your group, probably very kind of interactive. So we have weekly meetings, we have constant kind of discussions with our master students, PhD students, and so on. And I don't know, so it's based on looking what others do and looking at the literature and then being kind of inspired what's out there. So it's kind of and trying things and playing with things. And I don't think we have a specific process for that. It's kind of something which is based on us discussing things. So it's and looking for new opportunities. But I don't have a specific answer for you.
Okay, that's good. I mean, it seems like the chart you're showing right now, for example, with the challenge and potential near-body interactions, this could be used to help identify potential research areas to work in. For example, you could say, well, we want to look at what happens when we can narrow down the time to access to less than a second, or a few dozens of milliseconds. Or we want to look at what happens when we, you've got your curve there for the interaction space curving up after 2020. So what happens when we want to look at very low time to access versus very high interaction space area. So even building charts like this, I guess, helps in terms of identifying the areas that you think might be worth doing research in the future.
Yeah, that's right. Yeah, obviously, when you look at those kind of 6 challenges Steve Mann defined like in 1999, so they are still there, and then you could kind of think about how could I provide solutions for that. Yeah. When thinking about, I don't know, AR devices. Yeah. And I just thought about the access time and where it came from. This came from a collaboration with Nokia and Dan Ashbrook, you might know, who was at Nokia a while ago. And they had this loop device. I'm not sure whether you know it. They thought about a device which is also a pendant, which is something you wear around your neck. And it was activated by putting it in front of your eyes. And by moving it up, it was being switched on, and then you were instantly able to interact with it using touch interactions. And David was there as an intern at Nokia in the US at that time, and he came back with this idea of reducing the access time. Yeah, And I think very often those ideas come from like exchanges with other groups and so on. And it's actually quite important, this access time. It's also when I think about my personal hiking experiences. So when I, for instance, when I lead a group in the mountains and I have to maybe entertain the group and have to keep track where we're going and I have to look up information on my phone, then access time is really crucial because I don't have those 20 seconds to put my walking sticks away and to look something up on my phone. So it's really, really important, this access time, I would say.
Great, thanks for that. I'll let somebody else ask some questions.
Are there any more questions from anyone else?
Can I ask a question?
Sorry, who was that?
Ishan.
Ishan. Hi, Ishan. Yes, please do.
Yes. Hi, Enrico. This is very interesting, especially with the MoFlit. What do you call MoFlit? Something that's running on the arms. I'm wondering because toward the end of your presentations, you were mentioning about the attention, perception, and cognition. I'm wondering, are you thinking for like a future development? For example, if you use the MoFlit, say, for example, if somebody, when we're working on the computer and then a lot of information are bombarded, like we open a lot of, web browsers, it may give us a lot of cognitive load. So maybe that MoFlit can indicate in our hand if our cognitive load can too much, then it may go all the way here. So my question is, do you think that this kind of thing that you're developing will be integrated into the physiological informations that can measure the attentions or the cognitive load when somebody is using that device? Because I think it may help. Sometimes we don't know if we have too much cognitive load. So maybe if your device can give an indication, I think it could be useful for daily activities.
That's an interesting concept. So I think this this kind of issue of kind of information overflow, or that there are too many things which try to grab my attention. That's really an issue in many interfaces we have today, and there are other projects looking at this kind of attention management, in various ways. And then there's always the question, let's say you figure out that there's too much going on and you have to communicate it to the user somehow. Then the question is, how do you do that? And it would be maybe strange or awkward to use the visual channel for that. So it would be good to have a different channel. And very often, if the visual channel is not available or overloaded, it's good to look at tactile feedback or haptic feedback. And that's one of the advantages of the MoveLit device or of the other tactile devices, that the user is still being informed about something. Could be something as simple as, I know, too much attention or too much attention and a good level of attention and so on. And that's an interesting application scenario for the MoveLit.
Have you integrated physiological information into your devices that you're currently developing?
Not yet. That's something I mentioned at the end of my talk. So it's something we are currently looking at, or the other groups, because there's overt and covert attention. And first the question is, how do you measure attention? And a lot of kind of groups are looking into, like, I don't know, eye tracking to measure where you pay attention to. And then this is kind of something you could use as a sensor. And then the question is, once you kind of identified certain situations or behaviors of the user, how do you communicate that to the user? And then you could do this visually, which draws the attention to this visual aspect. And that's something you might want to avoid. And again, using kind of tactile or haptic feedback and device like the MoveLit device might be beneficial here.
Right. Thank you, Enrico.
Thank you.
Great. So I have another question here from Tamil. He says, so he has a question about insect. In real world context, the scent can possibly diffuse in the air and can be smelled by people around them. So do you have any suggestions on how this problem can be solved? and it's sort of also in line with what I thought of when I saw it, because like if others could also smell what you're releasing from the device, then would it be less private compared to just say a haptic feedback?
Yeah. These are really good questions. It's again something we didn't think of when starting to build the system. That's only something which came from the user study. In hindsight, it's obvious that this is kind of a challenge, but again, it's a nice example that you have to build systems to see the issue. It's an issue, yeah. Especially people also said that when you're riding a bike, then obviously the wind might blow the sand away, or if you're standing in an elevator, then others might smell it, yeah. So it's not a completely private device, yeah. But most devices aren't, yeah. So if you have if you have a smartphone and it vibrates, others hear the vibration as well, or if it kind of makes a sound, others hear it as well. Or if you look at the smartphone, others see the visual information as well. So we're kind of used to that, yeah, that others kind of pick up the information as well. And the question is now, and we kind of accept it, yeah, or got used to it. And there are kind of also social protocols around it. So nowadays it's not acceptable anymore if your smartphone rings in a lecture theater, which was kind of cool 20 years ago, but now it's kind of socially not acceptable anymore. And when it comes to those sense, it's also kind of interesting to look at the design space here, yeah, because you might end up only with like pleasant smells, yeah. And that if the 8 smells or 8 scents you have in your device are all pleasant, it's kind of maybe okay for you if they're being emitted in an elevator. Yeah. So it's maybe they're kind of seen as 8 different perfumes. All of them are pleasant. Only you know the meaning, and maybe that's okay for you if others kind of smell it as well, but it shouldn't be obtrusive, obviously. Yeah, it's if let's, I don't know, there might be also situations where you have an elevator with like 20 persons, all of them are using this device, and then you have kind of I don't know, an awkward situation in the elevator. That's actually a challenge somehow, but maybe you can turn it into an opportunity, yeah, that you, because some people always wear perfume, yeah. And with that, the perfume only changes, yeah, and you can assign a meaning to those changes. That might be a way to put it kind of positively.
Great. So I hope that answers the question, Tamil. Are there any more questions from anyone else? Well, I have a question, so it's a bit more general. I was just wondering, could you elaborate a little bit more about how you define the extension of the self? Because so from the examples that you gave earlier, for example, the definition by Thad, who say that when you cut it out to 2 seconds, it feels more like the extensions of the self. And some examples that you give about proximity, where the sensors, how close you are to you. So it sounds to me that one mentions about like time, and the other one mentions about space. So it seems like there's some kind of efficiency involved. Like the more efficient the interaction is, the more it is actually the extension of the self. So is there some way you can elaborate this a bit more, or is it like agency or something, agency, efficiency? Some way can you elaborate about this extension of true self, of the self?
I think you have to achieve many of the things I mentioned in the talk here. I think access time is one aspect, yeah. And with the project I mentioned here, these are more kind of, I don't know, often engineering approaches. You can touch the belt faster, you can approach the pockets of your trousers really quickly. Yeah? So it's about having them in arm's reach all the time, basically. Yeah? And something we didn't look at is kind of is attention. Yeah? So if you kind of, I don't know, if you have a computerized eyewear, and you have kind of the interaction means on your belt, so you have all the kind of the visual information there. You can provide input as well, but then the question again is how do you achieve this kind of 1 second or 2 seconds delay? And nowadays, I think it's not just like it's not just a device effort, yeah, to make it more accessible in a certain way. I think we have to look at the current, I don't know, mental state of the user, where he or she pays attention to. And this is something I guess you have to take into account. Yeah? So when thinking about this hiking situation, it would be great if the system would be aware, okay, I'm talking to somebody, maybe I'm looking at the horizon, and maybe I'm needing kind of navigation information. So if this, I think this situation awareness and this awareness of my attentional state, this is something which has to be achieved as well. Yeah, and that's something I would like to look at the future. I think that's one of the key issues now, and that's something I would like to look at as well. But this is really, really challenging. Yeah, that's, if you look at the research being conducted there, that's something which we wanted to achieve since I don't know, decades. But it's very challenging to provide solutions for. And I think the eyes are maybe a kind of, I don't know, a window towards our kind of attentional state. And with eye tracking technology being available in classes like ours, this might be a way towards that direction.
Do you think it has to be a wearable device? Like, for example, the phones that we have today, it's not a wearable, but I could probably take it off in 2 to 5 seconds from my pocket just to have a look at the notification, and it's really close to me as well. So how do you separate this? Like, for example, this is not a wearable device, just a phone. Or will it still be
that's a good question, because so the question is, where do you have your phone? So is it I think there are studies about the phone. I think when you're walking, it's very likely in your trouser pockets, if you're like wearing trousers as a male, for instance. But in most cases, it's laying somewhere. So since I don't know where my phone is right now, it's here on top of the screen. Forgot about that. But very often it's not in arm's reach. Yeah? Quite often it's not in arm's reach. And even if it's in arm's reach, you still have to put it out. You have to switch it on. You have to unlock it maybe. And this kind of taking it out, switching it on, unlocking it, this already takes, I don't know, 7 seconds. Yeah, and that extends everything by like 5 seconds. Yeah, but you want to come down to those 2 seconds, so it must be kind of there already, hopefully.
Right. Great. So we have a question by Rio. He says that comparing to the six ideas of the wearable computing design introduced in the 90s, the 6 points, is there any update or missing ideas you have found, or you feel like we need to bring into current modern wearable computer designs? Like, does it need to be updated, since that guidelines is pretty much quite old actually?
Yeah. I think if you spend some time looking at it, you might find aspects which weren't covered yet then. Yeah. But I think I would say those 6 are still there. Yeah. And there's no device available or no situation available where all those kind of attributes are kind of there, or where all those challenges are being solved. Yeah, if you think about, I don't know, current AR devices being used in certain situations, then I think you find an issue with almost every point. Yeah, so I would say we should try to solve those first, and then we might come up with other kind of solutions. And I think we could discuss each of them, like being controllable. I think this paper is really nice. So if you're interested in the field, have a look at the paper again. It's also nice. The examples Steve Mann provides are really, really nice, and it's really interesting to look at them in hindsight. Yeah, like now 20 plus years later, and they're still valid. Also the examples he brings, and with controllable, for instance, he has this notion that whatever you're doing and whatever the device is doing, you can always interrupt what the device is doing, and you can initiate like a new task, and it's instantly. So there's nothing happening beforehand. It's kind of instantly reacting to what you're doing. Yeah, so you kind of stop all the other tasks and start this new task at hand. And even this kind of aspect is still not being solved today. Yeah, and also this aspect of being unrestrictive. Yeah, might be solved when thinking about a smartwatch. Yeah, but not when thinking about today's AR devices. Yeah, because there are many situations where you can't wear them. Yeah. So it's, I think I would say that, okay, if you find something and this kind of, then you could provide solutions there, why not? Yeah, but if you look at the whole field, I would say let's focus on them first.
Great. I guess we have time for one last question. Do we have one last question from anyone? So I guess I'll ask the last question. So I was also interested about the movement. I think that's really interesting. So my question is, have you tried to test it out on other body parts, like the legs, the torso, maybe even the neck? And also, I was just wondering, did the participants come up with any feedback on side positive effects? Like, do they feel like they're getting a massage, or does it satisfy an itch on the arm when it moves to a certain point, something like that? Because I think an idea of a wearable device that moves around you is sort of interesting.
Yeah. I can't remember that we thought of other body parts. It was only challenging to have it moving on an arm, which is, it's kind of all about those little details once you start to build systems. So one issue I have is that the arms are very different in terms of the dimensions is different, and they're kind of small arms and wide arms, and still it must keep its location. That was quite challenging. And then other awkward side aspect is that if you have a hairy arm, then I think one of the first prototypes was really hurting because it pulled on the hair of your arm. So obviously you could, if you if you could have it on your leg, yeah, as something which kind of moves up and down. Why not? It kind of would be having it on your here might be interesting. I don't know. I forgot your second question.
About like, did they get report on any side positive effects? Like, does it feel like they're getting a massage, or like, if I have an itchy spot on my shoulder, I'll just move it up all the way up there, or something.
That might be an interesting side effect. So it's really feels like getting a massage because those kind of little wheels are moving up your arm. This is a kind of interesting side aspect as well. It could be like an information device, but could also provide massage as well. Why not? Yeah, but it's something we didn't think of then.
Great. All right. So so this brings us to the end of the seminar. Thanks so much, Enrico, for sharing your work with us.
Yeah, thanks for inviting me. It was really great to give this talk here today, and I would like to thank all of you for your questions.
Thanks, and thanks to all the participants as well. Yep.
And I hope to see you in the future somewhere physically. And Jun, good luck with your new position at KO.
Thank you, and thanks to everyone for joining. And hopefully we'll see you guys in the next seminar, maybe in about 2 weeks. So take care. Have a good day ahead.
Thank you.
Take care. Stay safe. Bye.
Bye-bye.